Hello engineers, welcome to the new video of the course, and in this particular video we are going to see the legitimate proof of the points that we had discussed in our previous session. So if you could remember, in our previous session I had discussed this particular point that there is certain parameter. If I vary this particular parameter, then I can behave this particular semiconductor as a conductor, or else I can treat this particular semiconductor as an insulator, right? So we are going to check that on the Tinkercad software with this particular circuit simulation. Okay, so first of all we will try to understand the circuit. Okay, of course most of you all guys maybe know that this is the symbol of diode. I know you all guys might be not that much familiar with the diodes since we are dealing with semiconductor, right? But it's my recommendation to you all guys, or rather I will recommend you that treat this diode as a black box. Meaning is that you are providing certain signal, and depending upon that signal you will be getting certain output. Don't worry about it. We won't be going in that detail way about diodes as of now, because we are on semiconductor, and just believe in me, your diode is a semiconductor device. Okay, just have faith in me and believe that your diode is a semiconductor device. And our main concern is this, that is varying the parameter, how exactly we are making our diode to behave as a conductor and as an insulator, right? So this is the point of our interest. Okay, so just focus on that. Okay, so let's go on the circuit diagram, and you can clearly see that I'm providing certain voltage, that is 0.5 volts. This is my diode. Okay, so when it comes to diode, so basically diode has 2 points or 2 terminals, that is p-type region or p-type or n-type, right? Again, I know most of you all guys may not be familiar with p-type region, what is p-type region and n-type region. Okay, so for them, treat it as positive terminal. So assume that this particular triangular like symbol, treat it as a positive terminal, and this line like symbol, treat it as negative terminal. Okay, great. I hope you are able to understand this. Okay, so you are connecting the positive side of the voltage source to the positive side of the diode, and negative side to the LED. So this is my LED. Okay, and the negative side of this voltage source to the negative terminal of LED. Okay, you take any electronic component. Okay, I mean most of the electronic component over which the polarization is mentioned, right? The polarization of any electronic component, if it is mentioned, so you can see that electronic components has 2 terminal, that is positive and negative. Okay, when it comes to capacitor, you will get 2 types of capacitor, maybe polarized, unpolarized, right? So when it comes to polarized capacitor, generally which deals with DC capacitor, so they have 2 terminals, that is positive and negative, right? A similar case is happening with diodes. Diode also has 2 terminals, that is positive and negative. Okay, p-type and n-type region. Great. So now what I'll do, I'll just simulate this particular circuit on the Tinkercad software, and we will check the result. Okay, we will check the result. Great. So let me go to the Tinkercad software, just a moment. Yeah, okay, so remember one thing, if you want to identify the positive and negative terminal of diode, so you just need to look upon this particular white line. So if you, I don't know if this is visible to you all guys, just a moment, let me just zoom it out. Yeah, I think now this is visible to you all guys. Yeah, you just look over here, this white color line. See this white color line, it indicates that this particular terminal, this is negative terminal or n-type region, and this particular part, this is my positive terminal, or this is my p-type region. Great. Okay, again I will repeat, this white color line, it indicates that this is my negative terminal or n-type region, and if there isn't anything over this side, so this is my p-type region or positive terminal of diode. Okay, great. So let me erase this particular thing. Yeah, alright. So now that I had erased, let me also attach one ammeter over here, so that we can actually get the value for current. Just a moment, let me attach ammeter. Let me check if multimeter is available. Just a second. Obviously it is available. Yeah, multimeter. I'll just paste it somewhere over here. Let me delete this particular wire, and let me, obviously since your current should move in this particular direction, so let me join this wire in this way, connect this particular wire in this way. Okay, so basically I'm connecting ammeter, and I hope you all guys know how to connect ammeter. We always connect ammeter in series. great. Okay, let me set it to ammeter, amperage. Okay, and yeah, that's fine. Okay, so now let me run this particular simulation. Okay, so you can clearly see 0 ampere of current, and you can clearly see that LED, it is in off condition. It is in off condition. Okay, and let me increase voltage to 0.5 because in the circuit I'm providing 0.5 volts, right? 0.5 volts. Okay, great. So yeah, you can clearly see 0.5 volts is nothing but 500 millivolts. Okay, so you can clearly see that my LED, it is in off condition and my current is still 0. Now let me increase the voltage maybe to 1 volt. You can clearly see even though my voltage is 1 volt, still the current is 0 and the LED, it is in off condition. Now let me increase the voltage to 2 volts. Okay, but before coming to that particular point, let me just deduce certain things out over here. Okay, I'll keep this particular point to 500 millivolts only. That means 0.5 volts. Yep, 0.5 volts, 0.5 volts. Okay, and let me run it. Yeah, so this is our point of interest. See, at 0.5 volts, yeah, just have a look over here. What I want to convey to you all guys is that, see, at 0.5 volts my diode is behaving as a insulator, or it is providing high resistance. You know, if it is providing high resistance, if at all it is providing high resistance, that means what? That means its resistivity is high and its conductivity is very less or negligible, right? But you know, can you guess the parameter? What exactly is this particular parameter over here in this particular scenario? What is the parameter? Okay, just look at this particular circuit and let me know that what exactly is the parameter in this particular circuit, like what we are varying so that this particular diode or this particular semiconductor device, it is behaving as an insulator. Just pause this video and try to think in your mind. Alright, I believe that you all guys might have lots of answer in your mind. Some might be wrong, some might be right, some might be incorrect, some might be correct, right? But let me give the appropriate answer. So the parameter over here is nothing but voltage. Parameter over here, it is nothing but voltage. Okay, if you look over here, I am providing voltage of around 0.5 volts and my LED, it is in off condition. So let me write over here, my LED, it is in off condition. Why? Because my diode is behaving as a insulator. So in this particular scenario, what we can conclude is that my diode is behaving as an insulator, insulator. Okay, so this is the most important conclusion, right? Now let's proceed further, and this time what I'm doing, I'm increasing the voltage to 2 volts, almost 4 times of the previous one. You can clearly see it is 0.5. So 0.5 into 4 or 0.5 multiplied by 4, which comes out around 2 volts, right? So this time I'm increasing the voltage. Let's see what exactly we get at the output. Okay, so let's suppose if I'm increasing to maybe 2 volts. Okay, enter. Okay, so you can see that the LED, it is in on condition. Let me increase it to maybe 2.5 maybe. Yeah, you can see the LED, it is in on condition. Let me increase it to 3 volts, directly to 3 volts. Okay, alright, so you can clearly see this time the LED, it is in on condition, and you can see the current is also flowing, right? Okay, so let me increase it step by step. Let me go to maybe 1.7 volts. Still there is no current. Let me go to 2 volts maybe. Just a second. 2 volts. Still there isn't any current. Let me just check if it no, they don't provide option of milliamperes. Okay, but you will get a certain current in milliampere. Also it can be in microampere. Let me increase it to maybe 2.5. Just a second. Yeah, 2.6, 2.5. You can see as you are increasing the voltage, the conductivity of this particular semiconductor, it increases and the resistivity is decreasing, right? You can clearly see that it is passing the energy. That means it is allowing the flow of current, right? It is passing the current, it is passing the energy. This is what I wanted to conclude, right? So what we saw is that over here, just a second. Yeah, as I'm increasing voltage, maybe I thought that the LED might glow at 2 volts, but yeah, even I'm also human being, I might also get wrong sometime, but yeah, at around 3 volts, maybe 3 volts, you can also take 5 volts, it's up to you. So at around 3 volts, that means what? If I am increasing the voltage, right, that means the parameter over here, as I mentioned, that particular parameter which was P, right, so which is nothing but voltage V, right. If I am increasing this particular voltage, so what is going to happen? You just have a look over here. I had clearly mentioned that this particular diode, you just see over here, this particular diode, it will act as a conductor. Okay, it will act as a conductor. That means what? If your voltage is increasing, so your conductivity, it is increasing. That means your resistivity, it is decreasing, right? Your resistivity, it is decreasing, so it will act as a pure conductor, right? And that's why your LED, it is in on condition. It is in on condition, right? If you check over here, it is in on condition and it is allowing the flow of current. That means it is allowing the energy to flow through it, right? Great. So this was the two major conclusion. That is, see, we concluded two things. That is this one. So by altering the parameter, we are behaving this particular semiconductor as a conductor or as an insulator. And we also concluded the second part. That means at a given time, see, at this particular time when my voltage is 0.5 volts, so my diode, it is behaving as a resistor, right? On contrary, when my when I'm providing, or rather when I'm increasing the voltage, so my diode, it is behaving as a conductor, right? Over here, over here my diode is behaving as an insulator. That means it is providing very high resistor, but in the very next interval, as I increase the voltage, it is behaving as a pure conductor, right? So this point also gets satisfied. That means it won't behave as a conductor and insulator at the same time, right? But if you alter certain parameter, so it will act as an insulator, or else it can act as a conductor by altering certain parameter. Over here, that parameter was voltage source, that is voltage, right? Great. So these are the two major conclusions that we saw in this particular session, and I believe that you understood the concept of semiconductors, that how exactly we can operate it as an insulator and how exactly we can operate it as a conductor. And that's why depending upon, or rather just by watching this particular what I can say, a characteristic only, we named it as semiconductor. That means what? It will behave as a conductor and it will behave as an insulator, but at different time intervals. Okay, great. So I really hope that you understood this particular concept in depth. Okay, and right now we are still at these 2 points only. We had covered these 2 points. Okay, I had covered these 2 points in detail way. Okay, but still, if you have any doubts, if you are facing any difficulties anywhere, it's my request to you, please ask me in the communication section. I will surely help you out there. Okay, so thank you for listening me patiently. I'm ending this video over here. Thank you.